Okay, in today's lesson, we are starting section 1.5, which is about rewriting equations and formulas. This one is going to feel a little bit weird sometimes because even though we are solving an equation for a specific variable, we're not necessarily going to get a numeric value that the variable is equal to. Like we might not get x equals 2. We might find out that x is equal to 2y minus 5. And all we're doing is we're going to rearrange things so that one variable is by itself. So what we're going to look at today are called literal equations. And a literal equation is an equation with two or more variables. The equations that we have been solving were just regular old equations. We've been looking at things like 2x minus 9 equals 15. Okay, that is just a regular, straightforward, direct equation. A literal equation might be something like 2x minus 9y equals 15. This one is a literal equation because it has two different variables in it. Okay, so we can rewrite a literal equation by solving for one of the variables in terms of the other. So let me show you a little bit of what that means when we say in terms of the other. So let's say that I have the equation 3x plus 4y equals 12. This is a literal equation. If I were to write this equation so that y is solved in terms of x, okay, so we would want it to look like this. The way this would look, and I'll show you how to get here in just a second, but the correct answer would be y is equal to negative 3/4 x plus 3. The reason that this is y solved in terms of x is because you can see that I have y by itself, and then on the other side we have an expression using x to describe what y is equal to. So on the right hand side, if I know what x is, then I could plug it in and my equation is already set up so that when I plug in x, I know what y is equal to. Now we could write this a different way so that x is solved in terms of y. And when we do that, it would look like x equals negative 4/3 x plus 4. This is what we would get when this x right here should be a y. X is equal to negative 4/3 y plus 4. Now for the same reasons, x is by itself. And then on the right side, negative 4/3 y plus 4 describes to me how I can figure out what x is. So if I knew, for example, that y was 6, I could plug it in, and then I would know what x is. So when we say in terms of, it means we want the variable by itself and the other variable to describe to us how to get it. So that is one of the things that we are going to be looking at. We will use the exact same inverse operations that we do when we solve a regular equation in one variable. We just have to be careful to remember things like terms and where we can divide and where we can't. So this first example, we're going to solve the equation for y. So what I am trying to do is get y by itself. So I have the 3y. That's the only y term that I have. There's nothing to distribute. There's nothing to combine because 3y and 4x are not like terms. But since I want the y by itself, that means that I need to get rid of this positive 4x. So what I'm going to do, just like we would with anything else, if I want to get rid of that, I'm going to do the opposite. So instead of plus 4x, I'm going to subtract 4x from both sides. Now notice I did not put my minus 4x under my 9. That was on purpose because 9 and negative 4x are not like terms. These make 0, and so all I have left over here is 3y equals, now I have 9 minus 4x. So you notice all we did was move the 4x from the left side to the right side. It doesn't have any like terms, so I can't condense it down any more than that. And so now, just like before, the last step to get y by itself would be to divide by 3. But here's what's very important. I cannot just divide one thing by 3. When I go to the right-hand side, I have to divide every single term by 3. Remember, that's how we keep balance in an equation. So I have y equals 9 divided by 3. That I can actually do. I get 3. And then I have negative 4 divided by 3. That doesn't divide out, so that tells me I'm just going to leave this as a fraction. Now remember all your rules. If I could reduce that, then I should. Like say if it was 4 over 6, then I would want to simplify that. And so even though it doesn't feel like we've gotten anywhere, we have solved this so that y is by itself, and the right-hand side describes how to figure it out. And that's our goal of what we are trying to do. So let's look at the second example and go ahead now and see if you can decide what your first step would be. We want to solve the equation for x, so that means the x is what we're trying to get by itself this time. The first thing that we should do is add 2y to both sides. These zero out, and I get 2x equals 5 plus 2y. So what is going to be my next step? I'm going to divide everything by 2. These make 1, so x is by itself, and that's equal to 5 divided by 2 doesn't come out nicely, and 5 over 2 doesn't reduce as a fraction, so I'm just going to leave it, 5 over 2, plus 2 divided by 2 just gives me 1y or y. And so here is my equation solved for x. Now, there is sort of an extra weird thing when we look at examples 3 and 4 here. So I want to solve this equation for x. Right now, we could describe this equation as being y written in terms of x and z. Because you see I have x's and z's over here this time. That's why we're going to have to be real careful. But y is by itself, and then the x's and z's describe how to get y. So this equation would be y written in terms of x and z. But we want x by itself. And what you notice here that's different is we have x in both of these terms. However, we cannot combine them together because one is a 3x, but the other one is a 5xz, and those are not like terms, so we can't combine them together. So we're going to do something that is kind of a little trick that we do in math. It's called factoring, and what it's basically doing is we're going to undistribute. Remember that if I had something like 2 times x plus 3, I would do 2 times x, that would give me 2x, and I would do 2 times 3. That would give me 6. I could also do something with variables where I could say a times b plus c. A times b would give me ab, and a times c would give me ac. Notice how after I distributed that a, both of these terms now had an a in it. So if we look at ours where they both have an x in it, that kind of tells us that that came from distributing, so we can do that in reverse. So we are going to rewrite our problem. Y equals, I'm going to just take the x out of both of those things. So I would just have 3 plus 5z. And now kind of in your mind, you can double check. If I do x times 3, I get 3x. And if I do x times 5z, I get 5xz, which is exactly what we want. So we know that we're on the right track. So in order to get x by itself, we need to get rid of all of this. And even though it feels like it shouldn't be allowed, now that this says x times 3 plus 5z, if I want to undo times 3 plus 5z, we can divide by 3 plus 5z. It feels weird to divide by more variables, but we can do that. And so on this side, these both cancel out because anything divided by itself is 1. And all we have left on this side is x. And then there's nothing that I can simplify over here. So this is just sort of a crazy looking fraction, 3 plus 5z. And that would be our answer. So let's go ahead and look at number 4. We want to get y by itself. So notice that I have y in both of these. So think about what our first step is going to be. We're going to undistribute or factor that y. What would that look like? We will take the y, and that would give me 2 plus p equals q. Y times 2 is 2y. Y times p is py. And now because I want my y's by itself, I need to undo this multiplication. So I'll divide by 2 plus p. These make 1. So y is equal to 9 divided by 2 plus p. And we can just stop right there. And this is what I have. So I know this is kind of weird and it feels a little bit difficult. But this is what we're going to practice today, and we'll practice this some more tomorrow. So do your very best, and I'll go over questions when I see you tomorrow.